Okay, so today we will continue the topic of drift current, inshallah. I told you that drift current is a topic from which there are so many calculations, some derivations, as well as it is linked with A2 as well. When I will teach you, inshallah, Hall's effect in electromagnetism, chapter of A2, then we will talk about drift current again, and its formula will be used there for the calculations and for understanding. Okay, so when I started drift current, I told you that actually there are electrons in the wires, but they are not alone. They have some uh, atoms, and some of the atoms have free electrons, as I have shown you that those all atoms which I have shown with positive charge, they are supposed to they have given the electrons as free electrons. So when an electron is rushed towards the positive terminal of the battery, what happens? It is trapped by that atom which is already ionized or which is already having a charge. Due to that, the atoms are the electrons are drifted, and due to that drift in the electrons, it creates it hinders their path, or it hinders their passage to move from one point to another point. So that current, which is due to drift of the electron, that was called your drift current, and the velocity by which they will move, that will be called your drift velocity. Got it? Today we will talk about drift velocity in detail and its calculations. So the velocity by which electrons are drifted, that is called your drift velocity. It would be asked to you to define drift velocity. Is screen visible to you? Screen visible है सबको? The velocity of Yahya and Mohsin, is
Yes.
screen visible?
Hey, it
Okay,
is visible.
okay. The velocity of electrons due to are while drifting, while they have drift. So that will be calculated. That would be asked to you to have some calculations, derivations. Drift velocity is basically equals to drift velocity is equals to I divided by N E A. Okay, or you can say that drift current is equals to NEAV, where we have to remember all these symbols, especially N matters a lot here. You people are asked what is N, and you people are asked what is significance of this N. So first of all, I would try to derive it, and then I will. Okay, first let's talk about that. What are these N's and everything? So when we have when we talk about this, the symbology, I is the drift current. What is I? It is drift current. Your E is the charge of an electron. It is constant. It does not have any change. And N is number density. It's very important. So I'm just going to write it with red. It is your number density, and it is asked to you deliberately, number density. You know what is the problem? Mostly the student used to write it is number of electrons. Yani we have this uh, intention that n is number of electrons, but it is not number of electrons. It is number of free electrons per unit volume. What is that? It is number of free electrons per unit volume, and that depends upon the nature of the material. It's very important here that n is more in, yeah, greater in metals, because in metals per unit per unit volume free electrons are greater. That is why they are good conductors. Okay, they are good conductors, and N is less in semiconductors. Semiconductors are basically those which have small number of free electrons per unit volume. So they have, they are not good conductors. They are medium conductors, actually, intermediate conductors. So this N matters a lot. So if I just give you the formula of N, that is total number of free electrons in a given amount of volume or per unit volume. So total number of free electrons per unit volume are divided by volume of the substance. So you can make a simple formula for N. N can be equals to capital N divided by V. From here, total number of electrons can be equals to number of free electrons per unit volume into volume of the substance. Are you getting my point?
Yes.
Okay. So moving towards the other aspects, what is A? A is basically area of cross section. What is A? A is area of cross section of a wire. Area of cross section. And that area of cross section, that is something like this. And if I want to calculate this area, that area will be equals to pi r square, and that will be pi d squared divided by 4. So we have to take care of this, that in case of drift velocity, although area is in the major formula or master formula, but diameter is also important, and there are some questions in which we have to talk about the drift velocity and diameter. So be careful about this. I will come back to the point. In case of drift velocity, the standard formula of the drift velocity is I divided by NEA. But in case of diameter, what will happen? In case of diameter, the formula will become V is equals to 4I divided by NE pi D square. Yani, what did I do? Simply, instead of area, I put pi D square divided by 4, and if I put pi d square divided by 4 here, 4 will be shifted to the numerator, and this remaining quantity will be n e into pi d square. Is this all clear? So from here, I
Yes.
have to make some relations or some factors which are effective in this all calculations, that v is directly proportional to I. I will reach to the calculations later on, but because there are some critical analysis question, so V is directly proportional to I. So you can reduce the current by any means. How to reduce the current? If you reduce the current by, if I is decreased by any mean, I will talk about that in my resistance topic, you know, by any mean, then we will decrease. Drift velocity will decrease. This is very important. And that any means that by increasing the resistance. When you are going to increase the resistance, again, there are several factors in which I can say that when you are going to increase the resistance, current would be decreased, and resistance depends upon different factors. I will talk about that as well. So you have to take care of the drift velocity, that how drift velocity matters or how drift velocity changes. Second thing, from this formula, drift velocity is inversely proportional to n, right? So drift velocity is inversely proportional to n. That equation or that relation tells you that in metals, drift velocity is insignificant. V in metals is very small. Yani Metals have very small drift current, drift velocity, because of their high number density, as I told you, because the number density in the metals is high, so that their V drift is less. But in semiconductors, V is more in semiconductors. ठीक है ना? So we have to take care of this statement as well, because the semiconductor materials have smaller n, so their V would be greater. And third and fourth aspect of that discussion is that V is inversely proportional to area of the wire. So from here, did you see that if the wires are thick, thick wires have less drift or smaller drift? Okay, they have smaller drift, and V increases as area increases. Sorry, area decreases. ठीक है ना? That is basically the same thing. But the only thing you have to take care in case of thickness, that V is inversely proportional to square of diameter. Here in this question, if area is divided by 2, your drift velocity would be multiplied by 2. But if diameter is divided by 2, your drift velocity would be multiplied by 4. This is very interesting thing, that there are some questions which would uh, be dealing with diameters of the wires. That's why I have given you this relation. So generally, for the comparison of two materials, of different dimensions, what do we need? Their area, their diameter, their current, everything is required. So you will write that V1 divided by V2 will be equals to I1 divided by I2 into N2 divided by N1 into A2 divided by A1. This is the master equation that will help you out to identify the parameters. For example, those parameters which I I told you, that the parameters which are directly proportional, I will put them in front, and those parameters which are inversely proportional, I will put them in the inverse relation. So in this one, this is your master equation of drift velocity in case of your area. In the same way, drift velocity in case of diameter is I1 divided by I2 into N2 divided by N1 into D2 divided by D1 whole square. Okay, D1 whole square. So this is another master equation, and that deals when diameters of the wires is given to you. And in all these equations, the key factor is you will just keep several factors constant. देखो कौन से factors constant रखोगे? For example, in series wires, if the wires are in series, I1 is equals to I2. So cut that one. Wires of same materials, these all are exam tricks. Wires of same materials, N1 is equals to N2. So cut that. Is it? Is it all clear to you? Hello everyone. आप लोग सुन रहे हो मुझे?
जी सर, सॉरी मैं थोड़ा नेट का मसले सर इधर, तो वो थोड़ी आपकी आवाज़ कट रही है, लेकिन आवाज़ वो आ रही है मुझे।
ओके ओके, कोई क्वेश्चन हुआ तो मुझे पूछना इन बिटवीन, ठीक है?
जी सर।
ओके. Aban, is Aban in the class? No. Yeah. Yeah. Good morning.
Yes, sir.
Are you there in the class?
Yes.
Okay. So you have to speak a little bit so that I can uh, think that I'm not speaking with my laptop.
Oh, okay.
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 Okay. Thank you. So here is the most important part of drift velocity, that is derivation. Derivation is asked to you for almost 3 marks. For the derivation, what we have to assume some dimensions. I mean, let's say I have a wire, and in that wire there is a sort of charge here. Let's say this is a charge, or this is an electron, and that electron is moving from point A to point B in time t, and it travels a length L. Right? Definitely, the length of the wire is given to you because the length is a factor which can define the resistance. So length is L, and time taken for the conductor is T. For this electron is T. And this is not the only one electron. There are several electrons in this wire which would have the same behavior, and they will reach from point A to point B in time t. That is why this current I will flow through. So if I say that your derivation starts from that current is equals to total charge divided by time. It is a defining equation of current, isn't it? Do you believe this thing? Okay. So what is current, by the way? Sorry, charge, by the way. Here you will take a pause and you will think the total charge is equals to what we have studied in the last lesson, number of sorry number of free electrons into charge of single electron. Got it? Is it? Are you getting it?
Yes.
Into volume of that material. For example, if there is V volume, total volume is V, and in that volume there are n number of electrons, so I can use that one, that formula. So this capital N is, sorry, this capital N is the total number of electrons. Sorry, just a correction. That was the total number of molecules, total number of free electrons into charge of a single electron. So as I told you earlier, that what is this N? This is the total number, है ना? So total number of electrons is number of electrons per unit volume into volume of that material into charge. Is it? Are you getting my point? This N is total number of free electrons. Okay, total number of free electrons, not electron per unit volume. But small n is the number of electrons per unit volume. Got it? It is number of electrons per unit volume. Sorry. Number of free electrons per unit volume. I will put some exam derivation in the code. Don't worry, because I'm going to make you clear. That's why I just make this scattered. Okay, now you will say that what is the volume of this wire or this entire conductor? That is, the volume is equal to It's area of cross section into length, isn't it? So your equation will be now formed as number of free electrons per unit volume into area of cross section of the wire into length of the wire into E. So actually, this is now the total charge in your wire. Got it? So in your exam, no need to write this all detail, just simple that you will write this equation first, and then you will do that is Q is equals to N E A L. That's it. Divided by T. Because I told you that how to calculate that all N into E into N into V. If you write this step, no issue at all. One step is, I think that is not a big deal. Capital V divided by T. And if you just further divide this all into area of cross section into length divided by T, now you know the charge, any single charge which is traveling L distance in T time, definitely it would have some velocity, isn't it? ऐसे ही होगा ना? So it is N into E into A into, you will write this as L divided by T. That just make it as a separate. So this is I is equals to N E A V. That's it. It is derived. If you are asked to make this V as a subject, then just separate this V. That is I divided by N E A. Simple. Is there any confusion in that one? हाँ जी बेटा. Yahya and Mohsin. Any
नहीं सर,
confusion in
clear.
this topic? Okay. So there would be different questions asked to you from this topic. मैंने पहले बताया कि lot of questions are there from the drift velocity. So I believe that when you will come across any question, it would be, I mean, you will be able to handle that. ठीक है? Should I switch to the next topic?
Yes.